Good morning, everybody. Cheers. Welcome to 2026. I'm a bit late, but Happy New Year. Wow, that was an anticlimax. There's no fireworks, there's no poppers, no anything. Just quiet. That's okay. Happy New Year, everybody. I hope you're all well. I am all over the map this morning. Had to sit and really concentrate and work out how I set up my stream again because I couldn't remember. But I think it's working. Oh, we got a party popper. Woohoo! Thanks, Dutchsaurus. I was actually expecting my camera to do that, I must have turned it off, when you say things like happy birthday, happy new year, and the fireworks happen. But, ooh, who hasn't been feeling well? So did everyone have a good break? New Year's, Christmas, all those things. I know not everyone here works. Some people are retired, like Johnny, what a life. But is everyone back to work? Oh, what? Dutchsaurus was sick. No. I hope you're better. Hope you're feeling better. Bull flu. What is bull flu? That's not a real thing. Surely that's not a real thing. Johnny, you don't work. You're semi-retired, and the semi bit means that when you're not retired, you're just playing games. You're streaming games, aren't you? It's a deadly man flu, but for bulls. Okay, I'm not sure what you're suggesting about Dutchsaurus there, but okay, I'll stay out of that one. I ended up working right through pretty much. When I say I took the main days off, I set up my computer coding, so I'm not sure that classifies as taking it off. I am semi-retired equals work all day, and now I am work-free for 5 days. So how is that semi-retired if you're working? Semi-retired means, I don't know what it means, actually. It's nothing I'm ever going to experience, so. Yeah. Oh, Matt made it first in the chat. Yay. Beat Mr. England. No way. What happened, Matt? Did you wet your bed? It's got to be the only reason you get out of bed early. We've got Beata. Hello, Beata. David Dessa. Hello. You wish it was Friday. Days don't make any difference for me. Friday is just like a Monday. But yeah, I get it. I understand. For people that have normal hour jobs, Friday is it's what you aim for. We don't speak about that, see, on wedding beds, don't we? Oops, I touched a nerve. Touched a nerve. We have Graham, Megabones. Hello. How you doing, mate? I hope you're well. Hope your wife is doing well. Antonio, hello. Who else have we got? I said to hi to Johnny. Jeremy. Hello, Jeremy. X-Micron. hi. We might have people lurking but aren't chatting. Yeah, that's okay. So I spent my last, well, since we chatted last, since I streamed last, I have been doing a tremendous amount of coding. Um, Spending a tremendous amount of time with Claude Code, um, and then cracking the shits and going to Codex for a bit and Gemini for a bit, and then realizing they were even worse, and then going back to Claude. It's been interesting, I have to say. Uh, Writing code with an agent is totally hit and miss, and these things are really not ready yet. But sometimes you get a nugget of gold. 50% of the time, it's piles of poo. Yeah, but yeah, I'm just gonna wait a bit and see if we get more people joining before I get into the stream proper. Stream proper. What? Where? Yeah. Thank you. Please finish that sentence. Please finish that sentence with a positive. Oh, my bin guy here is here to empty my empty bin. It's not. I haven't been at the office at the factory here since last week. I've been on site, so I didn't get my bin out last night. Cancer-free house. That is awesome. So awesome to hear, Graham. Really, really happy for you. I have been tinkering a little bit with some hardware designs, things that I'm not quite able to share yet. Although I have been I started collecting parts for them down there, but I really can't talk about it yet. It might be a disaster of an idea. It might not be. I don't know. So I have ordered some new chips from Espressive. I have some C5s, SP32 C5s, finally on the way. I'm going to look at. Well, I was going to look at today at possibly putting together or seeing if I can even get a tiny C5 board, if it'll even fit on a board. Espressive haven't released a footprint and symbol for it yet because it only just came out, which is fine. I could have made one, but then, well, I have to do something else today on stream. Well, I have to do it today, so I'm going to do it on stream. Start again on stream. I've been a naughty boy. I've been told I've been a naughty boy, and I have to get something finished. So, Teletronics, hello. But anyway, I've got some new chips coming from Espressive, and I've got some other new things that I've ordered. Oh, maybe we'll just open something on stream now. This is one of a few things. I don't know how this got here so early. This is for me to experiment with while I'm designing my other thing that I can't talk about yet. Hello, Discs Maker. So I'm designing something new. It's not a development board. It's going to be a product. Hey, why not? Because they go so well for me. They sell so many of them. Anyway, it's going to be a product. Hey, Andy Mouse. And I'm completely torn at the moment on if I'm going to use an ESP32 S3 as the brains or an ESP32 P4 as the brains. And so I have a box from Waveshare. There's actually a couple coming. I don't know why this one came by itself separately, because I ordered 3 different things from Waveshare. But I will show you what this is. It's lots of things inside it. I don't have my other camera set up right now. I'm sorry. But the main thing inside here. Ooh, okay, I'll show you what it all is. So, oh, this is not the one I thought I got. Okay, no, this is the one I thought I got. This is not one I thought arrived already. Okay, so this is an ESP32 P4 board and one of their Ethernet boards. So it's this board here. I'll see if I can find the link for it in a moment. But it's got a ESP32 P4 on the bottom. Bit hard to see. Get some light. It's got a P4. What? No cheat. Who? What? Where? And a whole bunch of other things on it. And it's got Ethernet. And so I want to have a play with it. I got the version that came with all the accessories. So it's got a camera. I don't know what camera it is. I think I got the 5 megapixel one. Can I see what it says? Oh, how funny! It says Raspberry Pi camera inside it. And a speaker, which whatever. But what it came with, and they don't sell these separately, I don't think, is it came with a little PoE module. But this is just, it's PoE. It's not PoE plus or anything. It only does like, whoops. I think it only does like 12. I think PoE is 15 watts, but I think it'll only go between 9 and 12, I think. And I believe it just connects like this, like that, where the big module is touching the header pins, which is really great. That's probably why they put Kapton tape around it. No, they put on the sides, but not on the top. Anyway, so I do have I've got that old Espressive P4 board here, but it doesn't have PoE. So I'm playing with something that has PoE, but it's got PoE plus. So I'm designing something that is powered by PoE plus and Ethernet, and I can't decide between the S3 and the P4. There are advantages and disadvantages between them. I'm giving way too much away at the moment, but yeah. So I bought one of their S3 versions and one of their P4 versions, and primarily to see what. Okay, so for those that aren't aware, the ESP32 S3, they took out, there's no Ethernet PHY inside it. There was in the ESP32, but the ESP32 S3, there's no Ethernet PHY. So you need to use an external chip for Ethernet, something like the WIZnet, the 5500. These are WIZnet 5500s, right? So WIZnet 5500, which connects to the S3 via SPI, and you get Ethernet. And you get, because it's SPI, you know, a 100 megabit Ethernet connection, you only get maybe 12 or 13 megabit because it's not a full bus. But for most things, I mean, that's way faster still than the Wi-Fi you're going to get on an ESP32, and you still get comms through it, right? So, hey, Dave Paul Jones, welcome, Happy New Year. So with the ESP32P4, that does have an Ethernet PHY in it. So it means that although you still need a separate Ethernet transceiver chip, when you put a separate Ethernet transceiver, you can basically get almost the full 100 megabit, right? You can get, you know, low 90s. So tremendously faster compared to an SPI Ethernet solution. Plus it supports more Ethernet functionality than you can get from the WIZnet. The downside is there's way more hardware, way more components and stuff and everything else needed on a P4 board. And there's nothing really else I need from the P4. You know, I don't need the higher cores. I don't need, you know, I only need like maybe 10 IO in total. So I'm not IO bound on the S3. And on the P4, I'd still have to use an external module if people wanted to use Wi-Fi instead of Ethernet. Where the S3, that's already built in. I can use a module on the S3. That's fine because there's nothing about it that prevents me from using a certified module, which helps for certification if I end up ever finishing the product and it works. Where on the P4 there is no module available. I could go module and I could go P4 with an external module, sure, like a C6 module or something. Anyway, there are options, but I don't know which way I want to go. So what I really need to do is compare apples to apples and try a P4 with full Ethernet and an S3 with the hampered Ethernet with the WISNet and see how bad they are. Like, you know what I mean? Compare. Because I can put together an S3 system design with probably half as many components, and I've got all the components here, like including the WISNets and whatever. I even found surface mount magnetic, surface mount Ethernet connectors. Actually, let me grab one. Hello, Mr. Agony. I hope you're not in agony. Okay, these are massive. I know you're all going to be wondering what I'm making. You're all going to have to wait. So these are, let's end it open. I really don't want it falling out. Not that end. Right. I'll open an end. Okay. So look at the size of that as an Ethernet connector compared to that. Well, it's not that much bigger, I guess. But that's a through-hole Ethernet, RJ45, and that is a surface mount one. I need surface mount, but this one also has all the magnetics inside, the magnetic decoupling, where this doesn't. So this needs an external chip. So, like I'm trying to come up with a design that is as optimized as possible. So anyway, I've got a whole bunch of stuff here, but I haven't even. I've started on the design, but I'm torn. Every time I think, yep, I'm going to go S3, then I do a bit more work, and then I think, nah, I should go to P4, whatever. So I caved, and I've got some of these coming, so I can test them first. And I can pretty much flesh out my idea as a prototype, that what I want to make using these boards anyway. Let me put these away. Yeah. Okay, so I said Sion's been a naughty boy. So Sion has not, I've got a KiCad project open here. Sion has not touched this project since he touched it last on a stream a while ago. And my client was a bit disappointed. So, and I'll explain why in a moment. So my testing board that I started working on that I needed, remember, some of you might remember, I started working on this board that allows me to test two devices on a panel via a Raspberry Pi with the, this obviously is not going to show up as anything. Not really. No, because it's not on a board, but using these connectors that will go to wires to pogos, right, on a test jig. So turns out I'm starting production on the actual boards this week, maybe Friday, or if not Friday, I'll do a setup over the weekend and I'll be running them on Monday. And I've not built the test jig. I've not even finished designing the test jig. So they can be manually tested, right? But, yeah, my client was really wanting them tested on a test jig. And look, he's totally right. It's not that they need to be tested on a test jig, but if I don't get this finished and I do the first production run without a test jig, I'm never going to get around to finishing the test jig, right? It was ages ago. It was months ago, but the problem is since then, I've designed another product which also goes into production, but I'm only building a short run of them. I built other testing devices, right? And I pretty much finished off all of the development work on all the stuff that I was doing, including that massive Python project, and did production of the products that they're for, and assembled a whole bunch of them. So they've got them in stock now. And so it's not like I've been sitting here doing nothing, right? I've been busy, and I've even, in between all of that, I've been shipping orders here and making, manufacturing here, and I'm actually way behind here. I'm about to run out today of Rooflow Master Pros and Feather S3s. I need to build like 1,000 Feather S3s. So yeah, it's not like I've just been sitting on my hands doing nothing, but for me, these boards pretty much test themselves. The boards that this is supposed to test, as long as the power works on them, as long as they power up and enumerate, yeah, they pretty much test themselves when I flash their firmware on them. Because if the firmware boots and works, then it works. It's self-contained, the board, right? But yeah, the idea of a test jig is so other people can test it, not just me. Thinking if anything's overrated, yeah. Whoa, that's I don't know anything about what's going on there. I mean, yeah, I don't know. Feel free to go into it, but so anyway, I did a little bit to this, but I haven't finished routing it. And I'm really torn still on a few of the things that I was thinking about doing. Like, I'm thinking that I might not do any of this the INA 260 power stuff. Like, it either powers up or it doesn't, right? And I've got these short detection switches. So all the so for a reminder, hello embedded garage. Wait, what is your garage embedded into? Are you new to the channel? If you are, welcome. So this is supposed to be a testing board for a panel of products that I've designed and manufactured for a client. So it's a way to test the boards on a panel before they get separated. Test them and flash them. Hello, Technubilis. Happy New Year to you too. It has been a while. How many weeks did I take off? It's only been 3 weeks. Was it gone just 3 weeks? I think it's just 3 weeks. Then you're not new. You're not welcome. Oh, no. I already said welcome to everybody and Happy New Year at the start. Maybe you came into the stream late and you missed it. I'm sorry. Oh, Bruce is here. So this board is, connects to a Raspberry Pi. The Raspberry Pi can test 2 of these boards at the same time on a panel. There's only 2 on a panel. And so they can get tested and flashed before they're separated from the panel, which, you know me, well, most of you know me, I test my boards like this. I depanelize and test my boards on test jigs. I do single board testing for all of my stuff because I test them the way a user tests them. But this is different. I test them the way a user uses them. But this is different, and I get how advantageous it would be if this was built already and all the firmware was designed already. But I have to finish designing it and build it and then write all the firmware for it. And there's no way that's happening before this production run starts. And I can't delay this production run, but I should still get this finished anyway. So some watching channel, as you know, creating content takes a lot of time. Yes, it does. With the front end for this application, it's just green, red, result, LED. No, this is actually going to be, against my better judgment, it's going to be a Pi with a screen, with a touch screen. And it will still be kind of like start, and then it'll be a green or red or whatever. You know, my client started down the road. Oh, we could, you know, do selective testing, and we could, you know, test this bit and test this bit. And we go, no, if you put the board down, you push a button, green is good, red is bad, and that's it, right? That's how you test. That's how you test quickly. But the so the good news is the amount of things that needs to be tested on the board is now less than half. So the production run we're doing of this design is actually my second revision of the redesign I did for them. So I did a first redesign of their product for them middle last year, which we're using internally, which worked great. But it was a double-sided board, and I managed to, like, it had an external Bluetooth module on it, even though it's running an S3. S3 has Bluetooth, but we're using Wi-Fi and ESP now concurrently on it, and you know, in the past, getting BLE going at the same time has been difficult on an SP32, but I got that working. So, like, for instance, we don't need that module, so that's come off now. And then some other things we don't need now has come off, which means it's now a single-sided assembly, which is great, better for me. I hate making double-sided assembly, like two-sided assembly. It's just painful. It is, right? So now it's not, but it also means that a lot of stuff we remove doesn't have to be tested now, and so that's been good. So I actually removed a whole bunch of stuff off this that was on there before. Thanks, Embedded Garage. So yeah, okay. So I what I need to do is just get stuck into doing this. Like, I don't really have a choice. I'm going to leave the INA out for the moment. And I'm trying to think, how can I get this bigger for you so I don't have to zoom in and out all the time, because I know that's jarring. I'll try not to zoom in and out. I do that just by habit, but I'll try not to. So that's 3.3 volts. Oh, see, I was still laying all this out. So I'm trying to think which one I'm going. I'll do the bottom ones first. I need to just finish laying out one set of this. I've already started here. Okay. So I need to get one. So it's basically two duplicate circuits on here, because we're testing two different boards. And even though the boards that I'm testing have native USB on them, right, and D+ and D- are broken out on the headers of the board, they're deliberately not broken out to test points or anything, or any way to interface with it externally, right? We don't want people messing with it. So the USB connectors are going to be, I'm just going to, come on. I'll put proper copper islands on this after. For now, I'm just going to route to the right spots, and I'll figure it out after. So these USBs are going to go to serial UART chips. I mentioned this last time. So the reason I'm using serial UART chips is there'll be fixed enumeration on the Pi. So the Raspberry Pi, hang on. every time you power up like an ESP, if you connect an ESP32 to it or an S3, something with native USB, and you power it up and enumerates, and then you power it down and power it up and enumerates again, it keeps changing the the ID. Like you get SDA1 or SDB1, then SDC1, then SDE1. You know what I mean? So we never know which one it is. So I don't want, every time I power up one of these boards that I'm testing, I don't want it to enumerate and give me a different USB thing. So I'm putting serial UARTs on there. So once it's powered up, they're fixed, right? They don't change because they don't get turned on and off. So that's why I'm doing it through there. So this will be a 4-layer board, but I'm just now, I want to electrically route it. So what happened there? Where's my D plus, D minus? Okay, it's a dot one, and where's dot one, D plus, D minus? What? Can anyone see? Not D plus, D minus. Sorry, I meant, right, okay, I'm an idiot. This D plus, D minus. I'm sorry for the zooming in and out. UART SPI bridge was getting lunch. No, test board, but I'm connecting to the devices that I'm testing via a serial UART. Interesting. Have to cross over. So yeah, just so I get consistency on, these are going to be very not length matched. That one's on top. Let's not do that. Let's do, sorry, changing my mind. I want this one on top. And that one from there. Oh, what is this? Battery power enable? I don't know. I'll put that in after. No, I think the other way around. Far out. Which way did I do it now? Why did they just go through? What have I done? Okay, I don't know what I've done. What have I done? Using top or bottom? Oh, I can't get them around. I can't get them around. So if I do this, oh, that is terrible. Then I can't do this one, right? It's always, doesn't really matter. Okay, unless I go What am I doing? Oh, Sion. Mr. Indecisive. That's a bit nasty, but I'm going to have to do it somewhere. I'm going to have to jump them over somewhere. But at least that means I don't have to switch layers here. Okay, so if I do that, terrible. It's terrible. I know. Oh, I can't do that here. But I can do it. Oh. This is the same USB. Yes, this. It should be connected inside the socket. Yeah, no, I don't understand why they... Well, they do that so you can prevent it from being double-sided or not, right? But I don't know why else... Why it would make sense to do it any other way. So D plus... Right, D plus and D minus are swapped. Switch these around. Switcheroony. Okay, so there's a lot of things about USB that is just annoying. This is just one of them. Wait, what? Oh, I've got them higher. Oh boy. Okay. I'm going to grab these. I'm going to lock these. Lock them. That's not even in line. Undo that. Let's align them horizontally. That's better. We'll lock them now. Oops. I'm going to maybe make them the same just for neatness. I know this is a bit overkill. Oh my god. I had locked items clicked. That's annoying. There we go. Oh, much more room than what I thought I had before. Or is that not? Oh, that's not even lined up. Excellent. So they're not even in the same spot. That minus 2.04. 0.67 millimeters. I need to move all of this 0.67 millimeters. Shift M. 0.67 millimeters. There we go. You could change the orientation in the USB socket. What do you mean orient? No, there's no impedance issues. There's multi-layer and no impedance issues on D plus D minus on these. It's USB 2. It's 100% forgiving. So yeah, they don't have to be length matched, and they don't have to be. Oh, come on, go away. But anyway, we'll get to that. That's fine. Okay, so oh my god, KiCad, what the hell are you doing? That one goes to there. Whoa. That one goes. to there, and that'll do for now. And then okay, good enough for the moment. See, nothing's laid out the same, top and bottom. I'll have to finish doing the top, and then I'll grab the bottom pieces and lay them all out to the same spot. Okay, so we're D plus D minus, and then we need, we have to put an auto reset circuit on it. Do I put auto reset on it, or do I just control IO0 and reset manually? I've got IO0 and reset broken out on here. So reset IO0, RX, TX. So I can toggle them manually. That was the whole point. So I could reset manually.
Cian, Chad has disconnected.
Okay, please reconnect. Thank you. If I put an auto reset circuit on it, then I could still reset it, but I don't have to worry about putting it into download mode. But I think I want to put it into download mode. I want to be able to manually control that. But then I'll need to stick those on the Pi header. Hey, Embedded Hobbyist. And all the cheese is under lock and key. What's this thing with cheese? What have I missed? Hey, Kev Spark. Kev Sparky, OC. Oh, Life and Cycling. Hello. Moo. Oh my God, we're taking a quick interlude. So I got to show you guys. I meant to show it at the start, and I forgot. So I posted this on Discord. Honestly, it's one of the funniest things I've one of the best uses of AI I've ever seen. Like it's given me hope. Hang on. Okay. It's a YouTube short. Mike, just in time. I got to play this for everyone. Sorry, got to do it. I want a dog that can do this. Is that not incredible? Look at the expression on the dog's face. Just what? Oh my God, I've watched this like a million times. This is what AI is for. I can't stop laughing at it. Oh my God. Okay. Sorry, that was it. I just had to share that. I had to because, oh my God. Oh my. RAM prices just went up to $5. What? I mean, $5 per kilobyte. Did no one like that? Did no one think that was funny? That was hilarious. Come on. Okay, so I've got RX and TX all the way over there. I don't think that makes sense. I think that needs to be swapped. Each dancing dog raises the prices. Oh, right. I see what you're saying. I don't care. I don't care. It is awesome. I'm going to go this. This is going to be 61. Don't worry about the traces. And that one is going to be 81. And they are going to go there. And they going to go there. I'll fix them up later. Okay. What is that? The little guy over there. So, maybe here. And do I want to rotate them? Maybe. I was thinking of getting this. These are all going to be plugs that wires go into pogos, but I think maybe wow. I'm thinking maybe I don't have to have them all grouped together. Maybe again I'll get it routed and then I'll worry about neatness afterwards. So I'm using KiCad 907, and 907 has done some weird things with moving traces again. They fixed some cool bugs, but you see how when I grabbed it before, only part of it moved up? Oh, yeah. Anyway, doing some weird things with selection. Too much play, not enough work. You talking about me? I like dogs, but could not eat a whole one. Like I try prompting Microsoft Copilot to lay out your board. No. I love AI for humorous things like that. But no, I don't do board design by AI. I don't do Copilot anything at all. Why have I got... Oh, interesting. Okay. I need to fix that. So these DTR traces... I need to rename, that's .2, .2 3 volts. Oh, that's interesting. Doesn't like that position. Oh, it doesn't like one of these. Okay. And then this is, I don't even need these connected. So let's just piss them off. Because I'm not doing the auto reset circuit. I'm not using those, all those, or they're not connect. I'm not connecting, they're not connect. Okay. I need to do that up here as well. That's dot one. Yeah, I draw the limit at, I don't mind getting help with coding. I don't let AI write my code. I don't mind it reviewing my code, making suggestions that I can choose to accept or not. I don't get it to do my board layout or design. Okay. I should get rid of a whole bunch of traces or things. Okay. So, oh God, this is all frustrating. It's very complex. I don't know about these INA. Let's just, for now, stick a wire in here. Okay, so the 23017s, the IO expanders. So this is going to be RPi SCL. Pi SDA. Just so it's clear. And 1 and 2. So I'm calling this .1, but I've got all these as 0s and 1s. So this should be MCP1 reset. This is interrupt 1, A, interrupt 1B. Oh my God, look at all this. I've started using Google anti-gravity instead of VS Code, much faster in general, and you can use all the extensions. Oh, can you really use all the extensions? Link to the dog. Oh, here. Sorry. It's on my Discord, but here it is here. It's so good. So good. I gotta say, Google. I mean, not that I trust all of them, but Google. I don't know if I can trust Google. Anyway, I've had Visual Studio Code crashing hard, taking down all my VS Studio Code sessions. It's been very frustrating. Yes, Apple Siri is going to use Google. I don't. I mean, it doesn't matter to me, but it seems like a really. Apple and Google used to hate each other. Okay, and then the header over here. That's Pi. I'm actually going to be using that. We're not going to be using an RGB LED on the board because we'll have a screen. Oh, actually, but maybe if we don't have a screen at the start. If I don't have a screen at the start, I can probably just write the UI. I could just write like I do on my test jigs, where I can. Oh my God, no, it's not going to happen because then I'll never get it done. If I get it working without a screen, then it's just never gonna happen. Never. Okay. I've got to hook these in. I also need a way to control the I/O. So I'm going to need what'll happen if will the CP2 or the CH92, is it? 01F. Is that going to get in a bad state if I don't hook up RTS, DTR? I'm going to need these on the Pi as well. I'm going to need, because I'm going to have to be able to control them from the Pi. Time for a latte. Well, it's always time for a latte here. Except I have a cold one. Damn. Wait, I could always use the IO expander. I've already got them hooked up to the IO expander. Oh, that's to test. That's an output. Input. That's to toggle them. Okay, no, I could just do that. I don't need them on the Pi. I'll do them on the IO expander. New product test board for a new product in the beginning. This is it's for a product that's going into production end of this week or Monday, but it's a client board. It's not a product of mine going out. So this is a test board for a client job. Just checking you set the MCP. Yeah. Address 0 is high on the second one, and address 1 and 2 is low. And on this one, they're all low. Yes, I've set them correctly. Okay, so I can just do that. I'll go straight from there. Okay, fine. Whoops. It's on the wrong window then. Okay, so I put them at, where did I put them? Zero and reset. Yeah, I know. Oh, that jumped. Why'd that jump? Awful. Fix another day. Okay. And do I need to hook up MC reset? Don't I have that on the headers? Did I not put them back in? No. That share the same reset, don't they? No. Should I reset them individually? I guess I should. Okay. I should have control to reset them individually. I'll put them here. Okay. Just in case they get stuck in a bad state, I can reset the IO expanders. Okay, what else? Interrupts I'm not actually using. I'm controlling and reading output. I don't need to know when a state changes, like I'm deliberately changing an output or reading an input as part of a test procedure. Okay. Maybe this header should be in the center between the two. Might make some sense. I'm not limited on how big this board can be either. So, I mean, I've not even put a, look, that is, I've not put a board thing around them at the moment. And maybe they should be mirrored. Anyway, work it out. Are you limited to say what order of magnitude the client boards you're building? Interested in the economics of scale for design and custom test jigs? Not really, no. But it's this is not about a scale thing. It's about a complexity thing. So yeah. Right. Should remove those. Yeah, this is about let me fix those. Where are they? This is about reliability of the thing. Yeah, these are not $20 boards, right, or $30 boards. So scale becomes irrelevant. And these boards are part of, there'll be X many boards. The product, the delivery product is, there'll be X many of these boards plus one of these and one of these and one of these and one of these and a whole bunch of these. In this, it's a solution, right? This is just one of the products, one of many of the products. Yeah, So, and they all need testing boards, and they all need, yeah. I hope that makes sense. Hey, Peter. Good morning. This is the test you guys started ages ago for that client board that now I'm out of time because they go into production pretty much this week. The boards will be here this week, like tomorrow, maybe Friday morning, and all the parts are here. They're already on feeders, so yeah, I'm kind of out of time. And when my client asked me yesterday, "Hey, how's the wait, why is that moved?" Oh, that's right, I forgot. Anyway, he said, "What's happening with the testing board? Is it ready to go?" And I went, "No." And he went, "What?" 46. I'm gonna try to get these all in fixed positions. Never do today what you can put off until. Yeah, well, my plan was to always just test these first ones as I flash them, like manually, because they're pretty easy to test. For me, they're easy to test when I'm flashing the firmware on them, but for other people to come in and go and do it, no, not so easy. I really don't know if okay. I don't like changing my grid size to get things into position. Okay, this is really frustrating. I'm just constantly changing my grid size is an annoying thing. So I'm just going to manually push things into a good position, which I should have done at the start. Bloody hell. Shout out to me if you see me do it again. They were in proper positions at some point, but then I moved. And this all obviously depends on where my board edge is. So it's going to stuff again, but at least if they're all aligned. This is the best latte you've made today. Well, thanks for the offer. Okay, so that's at 54. So that'll be 54 and I don't know, 61. Let's piss those off and do them again later. So I've been reluctant to hook any of this up because I don't know. Like I'm not fixed on the positions yet, but But at some point, I need to just commit. Whoops. Oh, give me a break. See, this selection thing has gone weird. Really gone weird. $54, $61, $71, too close. $81, too far. $76, $54. Interesting. I got those back to front. Okay, let me just switch those. Which ones are they? GPS and 3, GPS and 3. Those two. Hit X and switch them. X, switch. Why make it harder to route when it doesn't need to be? Hello, Mirag3304. Really? What happened here? It just stopped. It just stopped the trace. Oh, hello. Welcome to the stream. Where's that going? Right. And then where is, oops. Interesting. Okay. So that, you see what I've done? I haven't made them low enough. That's annoying. 61. 61 to 39. I have to move this down. Shift M, -1. Okay. What? Won't let me. Oh, is it touching something? TX0. Oh, wait. Oh my god, I killed TX0. I didn't realize. No one saw me do that. That's pretty funny. D. Okay. So they kind of line up. what is, oh, they're just grounds. Okay. So the 3v3s are, it's my 3v3 here. So this is coming in from barrel jack. Hey, wagon loads. In bat and ground. Okay, so the DUT one, the VBAT and the 5-volt in are going into the INA 260, which is now, I need to decide if I'm going to do that or not. I'm not sure what advantage I get out of doing this. Like, I'm just measuring the I don't know. The traces are there just for electrical connection. A lot of them are going to be copper pores instead. So I'm just, yeah, I'm just connecting things at the moment, working out where everything's going. Okay, the VBAT. I need the VBAT connected. Yes, yes, yes. I know. Thin trace. That's okay. As I said, for the moment. I don't know if I'm going to hook up the INAs. I'm going to leave them for the moment. I'm really torn on them. Really torn. So it's there just so I can measure that enough current's being pulled through to check that the battery's charging. There's no way of detecting is the battery charging or not, right? So the only way to really, I mean, because you get 4.2 volts out of the battery pin, the charge IC, whether it's charging or not. So the only way to check is the current, which is what the INA is for. But I can check if the battery is working because I can disconnect the 5 volts to the board and the board should still be it'll be running if it's off battery and it'll be communicating. So it's off. So if 5 volts works and the battery works, it doesn't really test the charge circuit. Bloody bother. Okay, I'm gonna have to have I got 2 different address lines? Yeah, I do. I'm gonna have to do it. I'm going to have to bring the INA. I keep saying INA. The I'm going to have to bring it into play, I think. Unless anyone's got another suggestion on how I can check if the charge is going to work. out, do what, pre-INA, what? .1, 5 volt, plus 5 volt, pre-INA. What's going on here? They should be the same. Why are they not saying .1 underscore plus 5 volt underscore pre underscore INA dot? Oh, there's an extra underscore. There's an extra underscore on here, but there isn't on here. Stupid names. .1 underscore .1. Have to change that. .1 underscore. Really? Oh, right, because these will be wrong. I should have just made one and then duplicated it afterwards. But KiCad is really not good at doing that. It just messes everything up. Totally messes everything up. Okay, now that'll work. Okay, so that's our in. That's our alert. What's the alert hooked up to? .1 INA alert. Where's that going to? Oh, over to the Pi. I have a problem with power tags 3 and little v and big 3. Yeah. And sometimes I do 3.3 and sometimes there's plus 3.3. Okay. Okay, we need that there and 5 volts in. Again, this will be copper. Will be copper. And the 5 volts in is going to down here. It's gonna, I reckon I need more capacitance than this, but okay, so 3 is got to go to there. This is all of this hooked up. No, okay, except for the stuff going to the Pi, which I've left myself no. Maybe I have. Okay, so I need the reset coming out, their address lines. I need these ones. Shocking. And you know what? I probably just go on the other side. Should just go on the other side. There and there. Okay, what else do I need coming out? Not connected, not connected. They're all connected. Good, good, good. Okay, So they're all connected. They're all connected. Right, 3.3 volts is good. Is there a chip that is specialized for battery level compared to using an ADC? Yeah, that's what I'm doing. Oh, for battery voltage? Yeah. Like, yeah. Fuel gauges. SQUiXL fuel gauges. In this case, although I can do voltage on this chip, I'm interested in the current draw, electrical engineering degree. I do not have an electrical engineering degree. I am completely self-taught. Asian yellow ice. That's okay. That one and that one, which conveniently, just for now, go to there. I hate doing first routing of stuff. Like, I really do. Like, it's just, I find, yeah. And no, I would not prefer an auto router at all. But really, KiCad. What's not super? What? Okay, what else needs to be hooked up? God, what a mess everywhere. Okay, 5 volts in. Dot power enable. That's got to go to the IO. Wait, no, that's on the Pi, isn't it? Dot power enable. Okay, I really need to put these in. Okay, what do I need? I need 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Battery power devices are post battery state to Jason. Fuel gauge chip is better. Huh? What? Is a fuel gauge chip better than an ADC? Reading the ADC? It depends. There's no. The short answer is maybe. It depends on the quality of the ADC. The problem with the fuel gauge is it doesn't know your battery, so it takes time. Depending on the fuel gauge, it takes time to learn about your battery. Needs to go through, multiple charge, discharge cycles, whatever. A fuel gauge though can give you easy things like you can kind of get a charge rate out of them. From my experience, they're not great, but you can get like a battery percentage. You can say, it's got 60% left, and it doesn't just do. It's not linear, right? It understands the battery type. So it really depends. That's the easiest answer for you. Sorry. So if that's not good enough. Okay. What? No more reliable battery state than just using voltage? Potentially. If you're disconnecting and reconnecting your battery all the time, if the fuel gauge gets powered down when your device is off, then it loses all its understanding of your battery, right? So it really depends on how it's implemented, which one you use, how often you disconnect the battery power, how often it does a charge cycle and stuff. So otherwise it'll just give you not necessarily accurate results. Like you could potentially get better results from a an ADC, maybe not an ESP32 ADC, but okay, all the way down there. So this is where we're going to maybe have some fun getting stuff routed. Did I put them on the wrong side? One is over there. Yeah, I did. Well done, Sion. They need to be on that side. Till fuel gauge AI is volatile. System scale using this feature does not provide reliable results, but that's on them. I just leave it plugged in. Right. Well, the problem again, the ADCs on an ESP32 are very difficult to work with, and they're not overly stable. So yeah. Like you can do that quite easily with an ADC still, because you need to know a range, right? It doesn't matter. Like you need to say if it's below X volts, go charge, and you're going to get a fairly decent. You know, you can get it. You can get it good enough. If you say if it's below 3.1 volts, I want to go charge, right? And so if your reading is 3.14 or 3.0, 8 or 7, it really doesn't make much of a difference, right? If you're trying to do something at an exact spot, well, that might be hard on an ADC, but it'll also be potentially hard on a fuel gauge. Again, depends on the fuel gauge you choose. It's all the way over there. Why are they? That's annoying. So now I can't even go through there. This is going to be spaghetti for a while. Oh, that one's up there. Did I click the wrong one? I did. That's the one I wanted. It's going to be spaghetti until I work all this out. If you got room for a fuel gauge, put a fuel gauge on. Sure, no harm in it. Oh, that's not going to work. I need to come all the way into there. No. This time 8:30. What am I going for? An hour and a half. Okay. So what else? Sure. I know. Grounds. Yeah. Okay. What if I just do this for now? Just to. Just to keep it happy. Let's just. Oops. I really feel like they've done something with. Okay. This is definitely feeling different in terms of moving things in 907. I'm doing this just so I can, whoops, do a fill, and I can get rid of the rat's nest stuff for the ground, to have a better idea of what is happening. So they're all the 3.3 volts. Okay, and what else? 3.3, 3.3. The fault in. Okay, so I need to get fault in. And I need to get the good news, once I've solved this routing, oh, that was silly. It's solved for both, right? Well, actually it's not, because the bottom is the opposite flip. Okay, maybe not. I'll shut my mouth. Yeah. Okay, what else needs to be? Yes, I'm just moving this. It'll be obvious in a minute why, I hope. So I can get a wire in there. I really need to set these up. I guess my concern is calculating power left versus power needed to get from where it is to the nearest charging station before it dies. Okay, so you don't want voltage, you want a percentage, but again, that's, I mean, a fuel gauge won't understand your use case. So you need to know what your rover takes in terms of current requirement, right, to do its thing. So if you don't know that, hey, Tishipu, tropical Switzerland. If you don't know that, then it doesn't matter what you measure your battery on, because if you don't know that, you need to know how much potential current you have left. You need to know how much current it takes for your vehicle to move 1 meter, right? And if you're 5 meters away from your thing and you only got 3 meters worth of power left, then you're in trouble, right? That you need to have already measured all that stuff. And again, yes, I know this is not how I'm doing it all. For now, I'm going to do, why have I got +3 and /3? Uh-oh. They're +3. Okay. I'm going to find some wrong. This is not how the power plan is going to be, but for now. Oh, right. I don't have. Yep. Okay. I'll fix that in a moment. So what else are we missing? 3.3. Okay, these ones here are the wrong ones. Okay, so this should be plus. plus 3.3. Let me check. Plus 3.3. Yeah. Okay. Okay. So what are we missing? Oh, what happened here? MCP reset. MCP1, 2. I want to move that on the other side. MCP1 reset needs to be over on this side. I don't know which one, but I have to check all of my I/O. Ooh, that was good decision. After no. That's annoying. Yeah, I'll have to check on my I/O usage on the Raspberry Pi. There's a couple of caveats with it. Okay. So what else? What's up here? What's that? 3 plus 3.3. Okay, SDL, SDA. Yuck, but okay, what else? What's that pointing to? Default in. Why are they? What is that? I wish I could click on them. So you say I need to know amp hours. I have amp hours needed to get there. Yeah, basically, like a voltage isn't going to help you. Like you can't say I need 3 volts to get from here to here, right? But you need to know how much current you got left. So it's you need to be calculating consumption versus availability. There might be an IC to do that for you already. I don't know. I can't see where these are pointing to. That oh, did I miss one? That's default in. Hang on. Where am I reading the fault? Oh no. .1 fault. Do I not have a .1 fault? Fault in. What is fault in? What is .1 fault in? Oh, have I just not renamed a that divider? But I must have named this wrong. No, .2 fault. So what is this pointing to? See this trace here? Oh wait, is that pointing to external 5 volt? Oh my god, it's pointing to this one. That's annoying. I thought it was pointing to here, right? But it's not. It's this. Look. See? Ah, okay. That's fine. So that looks to me like everything is then connected. I can't see any rat. I mean, that's the 5-volt power. And then what is that one? It looks like it's going to there. But where's it going to? It's just a stray something. And I don't understand where that... You see what I'm talking about? I don't know what that is. So it's just the power here I need to do. And what I need to do is... Oops.
Cian, Chad has disconnected.
Yes, yes. Again, I know, Trace. I'm just trying to get rid of all of the rat's nests to know everything's routed. And I think it is. I don't think I'm using that. I'll have to... that's actually got to be plus anyway, but I don't think I'll be doing the ground connection on these ground tests. Okay, so I mean, ideally I want to have the same circuit but flipped, right? Hey Matt, wait, but you were here first and then you came back late. I was congratulating you earlier for being first. But it didn't happen, did it? Hello, Infamy 4K. Okay. That was at 2 a.m. Okay, that was early. That wasn't fine. That you cheated. So we need to flip it, don't we? Or do I just make it the same? If I make it the same, some bits will be easy to route, some bits will be hard to route. I think it would look better if it was reversed. Oh, I can't decide. I also need to change this footprint. I need this to actually be change. I can't. Oh no, I hate when I do that. When I move it to another screen, it disappears. Okay. I need to. I can't show you where I'm getting this footprint from. It's a client footprint. Sorry. You watch, it'll pop up with a name anyway. That's going to be annoying if it does. Change. Okay, so this is the footprint I need for the barrel jack, because it is a it's a high voltage, high current jack. The other one that I normally use can, you know, maybe do 2 amps, maybe, and they say 50 volts, but I don't believe it. But this one is going to be a 6 amp supply. Oh, hello. How you doing, Pete? Look what I'm working on, Pete. This is a testing board for 2 devices on a panel, and I just routed one, and now I need to route the other, and I'm torn on... Like, if it was a Wayne KiCad, I could flip the positions. That'd be awesome. But it ain't going to happen. Okay, let's see what I can do. 46. Yeah, coffee on YouTube and unpopular. Learning how to make coffee. You know how to make coffee. What are you talking about? Yeah, like I'm not going to waste time trying to flip this. I'm going to go like that. I'm going to lock them. Actually, undo that. I'm going to group them. I'm going to lock the group. That way I can unlock it easily. So we're going to snappy, snappy. Come on. Snappy, snappy. I'm literally going to snap them all into the same spots. And I'm going to just move them down 180-degree symmetry. Huh? Well, it's either going to be mirrored. I don't want it rotate. It can't be rotated. They've got to be at the same ends. Nope, wrong one. That one's got to go there. And that one's Hall effect, which has got to go there. Main to go there. And that goes there. Okay. I don't know what that is for. It goes there. Oops. There. What is that? Oh, it's on the other MCP. Okay. That's that one. How crazy is this? Ba-bum. Oops. This is pretty anal, don't you think? I couldn't live with myself if I had them two identical circuits and they were just not in the same places where they're supposed to be. That would just drive my head in. Do my head in. Something like that. Oh, different footprints. What's going on here? I'm just going to fix this footprint. And want that there. Anyway, yep. And unlock it. Okay. Almost done. Believe it or not. Which is crazy. I will have to reroute it. Why is it not snapping properly? Snap. God, sometimes it will, sometimes it won't. No, they're miles apart, these connectors. They're stacks of room. Hang on, did I put at the wrong spot? I put the one in the wrong spot. That's why I didn't snap. Silly Seon. And no one even said anything. Again, wrong ones. I'll have to fix the footprints later. I updated some of the footprints and some I didn't. Okay. What's going on? Okay, 4 more, 5 more, 5 more. Three more. 2 more. What are these? Oh. Come on. Okay, so I know all these traces, they're gonna be screwed now. Okay. So I can now, because they're locked, I can go like this. I don't want those. I said I don't want those. Try that again. Okay, I want that. I want that. And I'm going to actually group them as well in case I accidentally drop them. And then if I go like this, oh, what is that? Oh, it's just a trace on the bottom. Fine. Like that would give me, ask, what am I doing? Shipu. This is a test board that is designed to test two boards on a panel, technically at the same time. Could be one at a time, could be at the same time, but two boards on a panel that have USB. They're ESP32S3 devices with a whole bunch of things, and so so it's a Raspberry Pi header. So it's a Raspberry Pi that controls the I/O expanders here and here, which break out to, well, I'll show you now that it's on a board. This should look a bit better. So these are 2.54 millimeter terminals, push terminals, right? That will go out through wires to pogo pins on a harness, on a test harness. And so these are battery connectors for, because each board battery controlled and has very high current battery charging, 880. Well, it can actually go up to an amp of battery charging, but it sits around between 790 and 810. So I have 5 volts coming in separately. There'll be a 5 volts coming in here, which will power the 5-volt rails for the boards and the battery charging, because as I said, that the battery could be pulling 800 milliamps plus the device plus whatever else. Like it's got Wi-Fi, Bluetooth running simultaneously, GPS, all sorts of things. So the current draw is high, way more than I can deliver via USB from the Raspberry Pi. So these will be connected to the Raspberry Pi and via serial UARTs that will talk to the boards, flash them, and test them. And these are through Pogos, and I can read all the stuff through the I/O expanders. There's a whole bunch of parts that are not missing, that are missing 3D parts. Anyway, but there's also, so this is a this here is for battery control. So it's a battery load switch. So I can turn the battery on and off. So I can turn the battery on, make sure it's charging. I check the charging through an INA 260. I can check the current, make sure the charge current is correct. And then, JLC is coming today. Pete, if you're still listening, JLC is coming today. So that checks my current, and then I can also cut 5 volts to the board, because that's going through this load switch. So this is a load switch and short circuit thing. So if it's drawing too much current, voltage, it'll cut. I can turn it off and then check that it runs via battery. Why are you putting... Right, because I wanted so these are identical circuits for 2 different devices. Right, so each one's got USB coming in. It's got all the same circuitry. I'm testing it's like 2 test jigs, right? But joined together, talking to one Pi. So I wanted the layout to be the same. I didn't want to lay it out where one side of the test jig looks like this and one side of the test jig looks like an elbow, right? I wanted them to be the same. So I laid them on top of each other so now these are identical in terms of placement, right? So all I need to do is just reroute them now, but everything's in exactly the same spot. Does that make sense? You know what? I can even do this. Let me show you something very cool in KiCad. I'm going to now unlock this. Or I'm going to remove the group, ungroup them, and unlock them, right? Check this out. I'll save first, just in case. I'm going to now grab at least these. I'll grab these traces, all of those. I'm going to grab all these. I'm just grabbing, actually. I want to do it again. I'm grabbing traces and vias, not components. Hello, Monster Mark 3D. Okay, so I've grabbed just all the traces. Yeah, check this out. What's a good one to use? That doesn't quite reach there. Let's use... I'll use that. Okay. So I'm going to Command D. I'm going to duplicate them. Yeah. And now, watch this. I used it, right? So I can snap it and snap. And now, look, it's all renamed itself. This whole thing now is routed. Ta-da! Is that pretty cool or what? Obviously, I need to bring these traces that are going down. I need to make them go up to the Pi. But look at this. This is all routed now. See? .2, .2, Hall effect, .2, .2. No. Half as many. No. So, yeah, KiCad will, if you move a trace, as long as you move it to 2 pads that are the same, it'll update the trace name on the nets for you. So that basically gave me the ability, look at that, these are now identical layouts, and I didn't have to reroute it. It's magic, except, why does that say CC.2 CC1? What's that pointing to? Oh, wait, why are they around the wrong way? Round. Oh, how funny. Okay. I put them in the position, but I didn't actually have them. Let's select my thing again. I need to ungroup. I forgot to ungroup them. That should be rotated. And that should be rotated. And now, see, those things are gone. Okay, so yeah, it does it for you. It's very cool. But if it's not touching properly, if it's not, you need to make sure that they snap, and then you need to make sure that it, you know, you can't do an incomplete one. It won't necessarily work. So I just now need to make these go the other way. Interesting. Where's that going to? Oh, lost its name. Okay. So I need to get I²C. It's probably the easiest ones to do to start with. Why can't you just duplicate the entire top circuit and make the second one? Because it'll change all the numbering, or all the reference IDs will change, and then they won't match my schematic. So you can't just duplicate parts that way, because then you get it'll decide what the reference names are. So that U3 here has to match up with my U3 here. I've already got all those things. So yeah, no, you can't do that. Just like you can't flip parts, right? You can rotate them, you can't flip them. I couldn't do a mirror. Yeah, there's just some things you can't do. That needs to be. Again, I'm just going to get them routed roughly. That can probably. Oh, God. That was probably a bad idea just doing that, but where okay, fault in is on that side. Oh, go the other way over there. And I wonder if I can move these over to be. Well, okay, we've got 1, 2, 3, 4, and move the MPC over to there. Okay, let's make some changes. So just to make it easy to route, like right now it's a bit crazy. Really? Okay, if I do that, that's now to there. Interesting. And now these are closer. That one goes straight up now. Which still, again, might be a bad idea, but come on. Hey, Nicholas. What a legend this guy is. Oh, my ESPs from him. You talking about me? No. No legends here. I mean, if you're talking about me, thanks for buying my products, but I would never consider myself. Wait, where are we going? I might have to swap some of these. Oh, maybe not. Building a custom keyboard with the USB right now. I'm in PCBs in the mail today, actually. Wicked. I've also got PCBs coming today. Exciting. Yeah, that's gonna suck. Oh, I can always come down here. As I said earlier, this is just about getting it all routed, and then I will go through. And I mean, I hate this stuff going over like that. Alt not connected. Ground. 5 volts in. Whoops, didn't mean to do that. Okay, let's just do a bit of 5 external 5 volt in solid. Oops. Whoops. What key have I got? I had a shortcut key to for removing. Anyway, yeah, I know. Anyway, I'll Legend of Australia had to be a crocodile hunter. I don't know. Okay, and then we're gonna have it got? Okay. It's probably going to be overkill. What I should do is stick a... Anyway, external, external, solid. Okay. Okay, so now we have nice fat 5-volt rail coming down. It's 40% low profile chalk red switches, surface landscape, wireless charging, OLED screen. Someone's making a what are they called? Shit. For switching. Like a HID. Oh my god. I can't think of the name. Someone help me. Anyone? Bueller? Anyone? Is anyone still watching? Anyone still here? How long have I been going for? 2:13. Okay, not fantastic, but okay. So now we've got a nice fat chunky pipe. What I should do is just give myself some more clearance around that. Okay, better. What does it think it's not connected to? 5-volt in. 5-volt in. What is it pointing to? I'm still getting that thing pointing across. Am I missing a... I can't see what that's pointing to. It's going past. Well, I'll have to do a DRC check. I wonder why this device is exclusive to I2C. Hello, Turan visitor. Which device is exclusively I2C? Okay. First time I'm going to run this. It's premature, but I'm... Oh, 1910. That's not too bad. Shorting 2 nets. _____. Oh, right. Oh, interesting. It didn't rename that one. So see, it failed to rename some of them. They must have not been exactly on the spot. Ah, I left an underscore out of some of them. Okay, I need to fix that. Remember, I fixed the underscores, but I didn't do it to all of them. Okay, pre. I don't know how many I need to fix. Underscore, 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 underscore. Right, that might have cleared that up. It did. 9 and 10 now. Okay. So I don't need that. Where'd my thing go? Oh, reset. Oh, I moved that. I must have moved it and deleted it by accident. Must have not, wrong size. Maybe I didn't lock it. Okay, there should be 2 more gone. Oh, what happened here? MCP1 reset. What's it not liking here? What? I think the error is clearance violation. How is this a clearance violation of what? Clearance 17 actual. Clearance to what? Hello? What are... Okay, there's something weird going on here. Marker, clearance violation. Oh, right. Oh, I'm sure there might be other ones. There might be other types that are... Like, what would you want it to be? SPI? That's interesting. Oh, right, the vise on top of each other? No, just look at that. I fixed that thing, and now it's gone to 7 and 5. Wait, where's that supposed to be? Ah, that's what that's doing. You know, current can pass through. You might want to look at a page with recommended layout to avoid. Yeah, right now I'm just doing electrical connection to make sure I've got everything in and routed. I don't want that. There's a lot that I need to redo and fix. 100%. Okay. Oh. Okay, hang on. There'll probably be another one. No. Getting there. Whoops. Down to 9. And again, what the hell is this? Clearance. Plus 3 read. Plus... Clearance of what? I what am I having clearance issues on? This is ridiculous. All right. I've got a clearance setting wrong somewhere. I'll have to look at this, track it down. This is this is such bullshit. You talking about me term? No, matrix macro pad. Nicholas, are you building a macro pad? I don't understand what is going on here. I really don't. 3.3 thermal reliefs. What exactly is the problem here? X, V. What is the not? I have no idea what this is. What it thinks it's close to. Oh, look at these traces. See, KiCad 7, baby. 9.7, 9.07. Oh, it thought it was too close to this trace. Okay, this must be. I got to have a. What setting have I got wrong? What's my board stuck up? I'm going to re-import from one of my boards. Import. Okay. Run. Whoa! 513 errors, violations now. Okay. Actually. 14. Oh, hang on. I know what some of these are. Because I changed the thing. Okay. Because I messed around with the layers before, and I shouldn't have messed around with the layers. Except, why are they not? Oh, I'm not refilling the zones, idiot. I keep clicking it, but I forgot to have zones redone. Okay, so 13. We're back to, it doesn't like something up here. Dot pre. Let's go 1. I don't know where these are pointing to. Why does it think these are disconnected? Oh my God, look at that. That'd be why. I have a trace going right through the middle here. That's funny. Yeah. So, okay, we want to move that down. That down. That up. It needs to be a fatter trace anyway, but that's what we want. How funny. Right through the guts. I split that thing in half. Here it doesn't matter. Run. 12 and 0. Okay. Missing. Okay, I'm missing some ground wires. So I should just put in around the place, which I haven't got to yet. Oops, there I go. I'll do proper ground stitching and stuff later. I just want to make sure that, again, they're all, that's a terrible place. As long as they're all, there's enough around to stitch everything. Get rid of those unconnected. And still one. CC1.2. Why are they both CC1? What? Oh my God, I called them both CC1. That's not good. Okay, that's CC2 now. Okay, we're down to just 9 violations. Front solder mask. Bridges, items, different things. Yep, that's okay. I don't care about solder mask. I'm just going to ignore that. Well, there you go. It was just... Wait, let's just make sure. Silk screen clipped. Inside courtyard. Footprint found in the library's footprint doesn't match light. Okay. No, bridges items are different nets. That's no good. But it doesn't. It doesn't really. What are you on about? Where's it bridging? Okay. I need to, yeah, they don't have any nets. That's fine. Oh. Okay, what else? Circles. Right, yeah, that's just the holes. That's okay. Console aperture. Yep. Yep. Okay. So we're good. We have a passing board now. It's not the neatest, but it's a passing board. 2.5 hours, 9:30. I'm going to have to wrap this up in a few minutes. It's a passing, good for the moment, it's a passing board. Now I can go through and literally relay everything out and make them better. Like that shouldn't be sitting just like that. Move that down and over. I could probably double side the caps to make that smaller so the 3.3 volts isn't so far away. I need to go through all the traces and clean all those up. Make sure that they're thick enough. I need to go through and do all of the ground wires. But overall, and then work out the shape of the board. But overall, this, no firmware, obviously, but this is now routed and done. I just need to, also, need to look at the INA. I need to set up a much better power in, power out stuff. Like, this, I mean, these are supposed to be solid. Why are they? Oh, thing. So this should be like this, right? Dot 1, 5 in. Dot 1, dot underscore 1, under 5 volt underscore in. Where's that? Here. Solid. 0.127. 127. So this will be like a where's that going to? Yeah. Yeah, that'll be like that. Yes, I need a ground. Right, so that there won't be traces. So yeah, I just need to go through and will that actually? Yeah, didn't think so. So I need to do stuff like that everywhere. And yeah. Okay. Well, closer than it's ever been. It doesn't need like a case or anything, but I need to put probably some mounting holes, or maybe it'll need some feet or something. They're not the right 3D model, by the way, just so you know, but good enough to give an indication of what it is. Cool. Okay. I'll get this. I'll have to get this off. It's not going to go off today. Like there's quite a bit more work I need to clean up and stuff, but I need to wrap the stream up. I have to start some, get the line ready, start some manufacturing today, and I've also got a client meeting at 11:30. I need to tidy up a little bit in here. It's a bit embarrassing. You can't see the mess, but I can see all the mess. Thanks for sticking around for so long. Those of you that did. So I think 26 people here. Yeah. Amazing. I almost got it ready. So, yeah. Hopefully, I'm not still doing this next week. I got something else that I want to work on next week. So, but if I'm still doing this next week, then it means I failed again to get it finished. But let you all know. Okay. Thanks, Johnny. Catch you all later. Have a great week. Have a good sleep for those of you that are about to go to sleep or already sleeping. And yeah, those working. Yep, sucks, doesn't it? Oh, Rob. Hello, Rob. Rob was lurking. Cool. I hope you're well, Rob. Happy New Year. Happy New Year, everyone. Take care. I'll catch you all next week. Okay? Bye.